Hello everyone. In this video I'm going to cover two lessons, which are lesson 2.3 functions and lesson 2.5 equations of lines and linear models. Let me start with lesson 2.3 functions. A relation is a set of ordered pairs, but to be a function there's a certain criteria that those ordered pairs should meet. Okay, and that's my criteria. And for each distinct value of first component of the ordered pair, the ordered pair, as you know, consists of x and y. Like first component should be x, and there should be exactly one value of second component. So for each x value, there should be exactly one y value. But let me make this clear and easier. Okay, x shouldn't repeat. Okay, x shouldn't repeat to be a function. Okay, if we see x repeating, not a function. But if we see x not repeating, it's a function. Okay, let me show you one example. It's gonna make much more sense. That's a super easy deal. So we have a relations over here. Decide which ones are function. So look at the first f function here, f relation. Look at my x values. X shouldn't repeat, right? X shouldn't repeat. X, 1, negative 2 and 3. So there's no repeating value, so this one should be a function. Have a look at next one. Look at my x values, 1, 1, 1 and 2. Oh my goodness, you see like 1, 1, 1 is repeating. So if you see repeating, we should say that it's not a function. Alright, so let's look at the last one, negative 4, negative 2, negative 2. So because of those negative 2's repeating, so it should be not function. It's that easy. Take it easy. Please pause the video, have a try those everyone. Put check marks or X and have a try to solve those. So let's move on to next part, domain and range. So x domain represents my x values and range represents y values. So let's have a look at this question. Give domain and range for each relation. Tell are they function or not. Have a look at for this one. Let's see domain first and range. So what was the domain was x values. What's my x values here? 3, right? And 4. Another 4. Don't write, but once is enough. And 6. So here we are. We are done with this one. Let's have a look at the range of this relation. So range was y values, which are here, right? So it should be negative 1, 2, 5 and 8. Okay, and then let's decide it is a function or not. So to decide, let's check the x values. Are they repeating? Oh, since I see that 4 is repeating, so this one should be not function. All right, look at the b. What was my domain? What's my range? Domain should be x values. Those are my x values. 4, 6, 7, negative 3. Range is here. 100, 200 and 300. Like since I don't see any repeating numbers here, I should say that it's a function. We're all good. Let's have a look at the last one here, table. X values domain should be negative 5, 0 and 5. And range should be y values, which are 2. Just put ones. Is a function or not? Check your x values. Are they repeating? So nope. So answer should be yes, this function is a function. So this is your turn examples. Please pause the video and solve those questions. Next part, so give domain and range each relation. So for this one, domain should be my x values. Like we have ordered pair, what's their x values? 1. X value is 4. X value is 0. X value here, negative 1. That's my domain. And range should be what? My y values, 2, negative 3, negative 1 and 1. That's my range. And on this case, like domain represents x values, right? And this graph cover which x numbers, as you've seen, from -4 to 4. So domain should be -4 to 4. Like since I should go with bracket because it goes through 4, it touch 4, so I should include those -4 and 4. And range should be what? It's coming from like -6 all the way up to 6. So range should be -6 to 6. That's how I show it. And in this case, domain and range, like domain is x values, right? This graph cover all those positive x values, all those negative x values. So we should say negative infinity to positive infinity. Or you can say all real numbers. So that's fine as well. All real numbers. Like same thing for range. Like it's gonna cover all those positive y values. It's gonna cover all those negative numbers. So we are good to say negative infinity to positive infinity. Let's have a look at the last one here. Let's look at the domain first. X values. Those will be covered because this graph goes infinity. This graph goes infinity here. So it's gonna cover all those numbers. So I'm gonna say negative infinity to positive infinity. But range is a little bit different, right? It goes here and all the way up, right? So it's gonna cover all those numbers, but there's no way to go down here. It's gonna start at -3 and it's gonna go all the way up. So that's how I represent it. That's how I say it. So here we are. Those are your turns for each. Please decide domain and range. Vertical line test. So if every vertical line test intersects the graph of a relation in no more than 1 point, then relation is a function. So we're gonna do this. If we're gonna have some graph and we're gonna decide are they function or not. So that's my criteria. So your vertical line crossed once, we are fine. Okay, we are fine. It's a function. But if your vertical line crossed the graph more than once, we're gonna say it's not a function. Let me show you a few examples. In this case, let's say I have a vertical line, something like this. Let me make it. Here we are. I got this vertical line. How many times it crossed my graph? Like once over here, once over here. More than once. So we should say not function. All right. So let's have a look at this example. Let's say I have a vertical line go like this. It's gonna cross once. Even if you go down like this, it's gonna cross once anyway, right? It's go like this. Cross once anyway. So we should say yes, this one should be a function. If you look at this one, like have a vertical line, cross once, oh, it should be fine. It should be a function. Even if we have ordered pair like this, look at this one. This vertical line, cross once point, cross once point, cross once point, cross one point. So like there's no, it doesn't cross more than once. So we should say it's a function as well. Okay, vertical line. So take it easy. Just follow this rule and it's gonna work out. And please have a try this by using vertical line test. Decide which ones are a function, which ones are not. So what about like, if we have some equation? How do we decide they are functions or not? Okay. First of all, there's an easy way for this one. Okay. We can do this. Like we can graph and see. Okay. Y equals x plus 4. Let's go to Desmos. Okay. And let's graph it. Y equals x plus 4. If we have such a graph, like remember vertical line rule, I'm gonna have a vertical line like this, cross once, we are fine. So it's a function. It's a function. Okay. Here we are. And then look at B, square root of 2x minus 1. Square root of 2x minus 1. Here we are. So that's my graph, like vertical line, go like this, go like this. It's gonna cross once anyway, so it should be a function as well. Okay. And lastly, have a look at this one, 5 over x minus 1. 5 over x minus 1. So this one also should be a function because it's the vertical line will cross once. So they're all function. And this okay, domain and range. So domain and for range for A, like based on the graph we can see clearly. Also you can go back to graphs and see domain and range easily, but for this one it should be all real numbers, negative infinity to positive infinity here. Okay, and also for this one, okay, let's look at the E first. And there is a 1 point here, make it undefined, so we should exclude that point. If you put that 1 here, it's going to be like 5 over 0, which is undefined. So that's why we shouldn't include 1. Okay, so domain and range. Domain by x point we should exclude 1. I'm gonna say negative infinity to 1 and 1 to infinity. But again, do not, I go with parentheses, which means do not include 1 there. But the range should be fine all negative and positive numbers, negative infinity to positive infinity. And for B, again, go back to graph and you can see clearly, but I want to show you this way. Let me go down here. Let me do B here. Okay. So it's easy to see on graph, but if you look at the equation, there's a restriction here. In the square root, we cannot have negative numbers. So we should say that 2x minus 1 always should be bigger than or equal to 0, because it cannot be negative number, it make it undefined, right? So I'm gonna do plus 1 here, so 2x bigger than equal to 1, so divide both sides by 2, so x should be bigger than 1/2, right? So my domain should be bigger than 1/2, so like go like this, have 1/2 0.5 to infinity, right? And the range, and my outcome is always positive, so I'm gonna say 0 to infinity. Here we are, that's my answer. But my otherwise graph, and you can see easy on the graph. And those are your turn examples. So last part, oh, there are more parts. Okay, let's work on functions. How do we evaluate functions? Let's say we got this function fx x squared plus 5, and we're looking for f2. Okay, so to do so, I'm going to do this. Now, I'm going to take this 2 and write in x. Now, that's all what we do. So I'm going to have f of 2 equals, and here, 2 squared plus 5. 2 squared was 4 plus 5. So f of 2 should be equal to 9. That's my answer. But that's how we evaluate them. Like all what you're gonna do, replace with x. That's all what we do. So to find g of 10, I plug in here 10. That's it. So it should be 2 times 10 minus 5. 2 times 10 is 20 minus 5. So it should be 15. So g of 10 should be equal to 15, everyone. All right. Here we go. Please pause the video. I want you to solve those. Here we are. So for each function, find f3. So for A, it's super easy to find f3. Just plug in here so we can see clearly. So it should be 3 times 3 minus 7. 3 times 3 is 9 minus 7. So it should be 2. For A, right? So f3 should be equal to 2. And we are good. Have a look at the B. Okay, what's the f3 for B? I'm going to do this way. Like this 3, like I plug in x, right? Which means my x value is 3. So when x is 3, what's my y value? Look at here, not negative 3, 0, oh 3, here we are. I find 3. 3 goes to what? 3 corresponds to 1. So which means f3 should be equal to 1, and that's my answer. Okay. And here, like 3 goes to which number? So 3 goes to 5. Like for this function, f3 should be equal to 5. And that's it. It's that easy. For this case, I'm looking for what? F of 3, right? X is 3. So x3 should be somewhere here. And let's see it corresponds to which number. Let's go up here. It's gonna go to this number. So as you see, so f of 3 should be equal to 4. And that's my answer. So please pause the video and solve those questions. For each function, please find f2, f of 2. And also please try those based on each graph. Let's find f4, f4. Let me just show you one. So in this case, f4 means, right, f of 4, so x should be 4. x4 is here. It goes to another 4. So my answer should be equal to 4, right? And please solve those. So we are done with lesson 2-3. It's time to move on to next lesson 2-5. Equation of lines and linear models. First of all, like, we have to remember this rule, like slope guy. If you have a line going this way, it should have a positive slope. If you have a line going this way, we should have a negative slope. If you have a vertical line, this line has undefined slope, and if you have a horizontal line, it has a slope of 0. Those are 0, and that's the undefined. And if you have two order pair, that's the formula to find my slope. y2 minus y1, x2 minus x1. And I will show you some examples on this. So first of all, point slope form. So this is how it looks like, y minus y1 and x minus x1. In this form, if we have order pair given and if we know the slope, so we can write in this form because you have a point and you have a slope. Right? Let's have a look at the first question. Write an equation of the line through point -4 and 1 and having slope -3. That's my order pair, so this one should be x1 and y1, and my slope should be m, right? So let's write them in my formula, in my form, point slope form. Y minus y1, it's 1, equals to m -3 x minus x1, which is -4. So it should be y minus 1, -3 x plus 4. Look, that's the equation of the line goes through this point and having slope of -3, and that's my answer. Look, please, I want you to do the same thing for these two questions. So next form is slope-intercept form. Slope-intercept form is y equals mx plus b. It's called slope-intercept form because you can see clearly and easily slope and y-intercept. So this m is your slope and this number is going to be your y-intercept. Let's have a look at a few examples here. In this case, if we have 3x plus 5, so my slope should be the number right from x, which is 3, and y-intercept should be this number, which is 5. So as you see, I can see clearly and easily slope and y-intercept. So in this case, my slope should be -2, and my y-intercept should be not 5, it should be -5. And lastly, here it should be -1, and y-intercept should be 10. So find the slope and y-intercept of the line. I'm gonna go this way. I'm looking for slope and y-intercept, right? So if I get this equation in this form, I can see clearly slope, which is here, and y-intercept, which is here. So just convert this to this way, so I can see clearly. So my only goal, get y alone, right? As you've seen, y should be alone. Let's try to do so. I'm gonna subtract 4x from both sides. These two will cancel each other. 5y equals to negative 4x minus 10. And lastly, I should divide by 5. What do we get then? These two cancel. Y equals negative 4 over 5x. And this part, if we divide them, I should get negative 2. So right now I can see clearly slope and y-intercept. So slope should be negative 4 over 5 and y-intercept should be negative 2. That's how we do so. So please pause the video, find the slope and y-intercept of each line. So you can see clearly on this one and this one, but on this one, as I done here, try to get y alone and you can see easily. Write an equation of the line through 2 points. And then, okay. I'm gonna do this one. Y equals mx plus b. Am I right? So that's my equation. I'm gonna do this one. So I'm gonna find slope first. So to find slope, like remember the formula, it was y2 minus y1 divided by x2 minus x1. Okay, let me. So I have a two order pairs. Let's find. This one should be x1, y1. This one should be x2 and y2. So y2 minus y1, 4 minus 1 divided by x2 minus x1, 2 minus 1. So it should be 3 over 1, which is 3. So my slope is 3, right? M is 3. So let's take this, write in my equation here. So y equals 3x plus b. I'm almost there. I'm so close to get my equation ready. The only missing one is b. How do we find b? I'm gonna go this way. Like you can pick either point over here. You can pick any order pair you want. But I wanna pick 1 and 1. And as you know, if you get 1 and 1, your x should be your first number, 1, and your y should be 1. I'm gonna write them in the equation so I can calculate b here. So 1 equals 3 times 1 plus b. 1 equals 3 times 1 is 3 plus b. To get b alone, subtract 3, subtract 3. These two cancel. B equals negative 2. Oh, I got, like we know the m here, right? It was ready, and this is over here. So by final equation should be look like this. Y equals, right, 3x and plus b, and b is negative 2. So that's the equation of the line through 1, 1 and 2, 4, and that's how we find it. And here we are. Next question. Use the graph to answer the following. Identify slope, y-intercept, x-intercept, and write the equation. Alright, let's find slope. And slope is m, right? And like remember this slope phase, like all the way up here. I got the formula here, and I'm gonna do this. Like you can, like there are two order pairs here, this one and this one. You can use the formula, I don't mind, like y2 minus y1, x2 minus x1. But slope was rise over run, right? Like basic high school algebra information, rise over run. So let's see my rise over here, and let's see my run here. It should be, you go 1 units up, right? And run is 1, 2, 3 units. If you're going that way, like remember slope phase, so this one should have a negative slope. That's my slope. Y-intercept is here. Y-intercept should be what? Y-intercept means your graph crosses the y-axis at which point? At point negative 1. So So y-intercept should be -1. And x-intercept should be the graph cross x-axis at which point? At point -3. X-intercept is -3. And write an equation that defines m. So I'm gonna go with this one, like y equals mx plus b. Am I right? Because I know m, slope, right, is here, and also I know what b is, y-intercept, which is here. So -1/3 x plus b, which is -1 over here. So that's the equation of this function. And then please pause the video, do the same thing for these graphs. Find slope, y-intercept, x-intercept, and get the equation of each function. And next, if we have a horizontal and vertical line, how do we name them? How do we get the equation? And I have a super tricky, easy way for this. Let's say I got those graphs, all right? On this one, let's assume it goes at 3, all right? Not 3. Okay. On this one, let's assume it goes at -3. Okay, to be on the same page. This one, let's assume it goes at 4. And this one, let's assume it goes at -4. Okay. To find data equation, I go this way. So my graph cross which axis? X or Y? So it cross y-axis. So put there y. At which point? It goes through point 3. So which means it's y equals 3. So that's the equation of it, and that's it. That's your answer. On this one, so your graph goes through which line? X or Y? It goes through y. So y equals at which point? -3. So that's the answer of my question. That's the equation of this graph. For this case, this graph goes through which lane? Which axis? X or Y? It goes through x-axis. Put the x at which point? -4. And lastly here, it goes through x. Put the x at which point? 4. That's how I solve them. Like, that's the extra information over here. If needed, you can refer back here.